solve this question where we are asked to calculate the pressure and temperature at the end of the compression, and the before the compression we have been given the pressure and temperature, and we have been given the compression ratio. So if you know the basic like we have been given a diesel cycle. So if you know the basic diesel cycle, it will be very easy to calculate. So let us say this is our diesel cycle, which we have 4 processes, where this is where the heat is supplied, this is where the work is done. There 4 to 1 is heat rejected, and 1 to 2 is nothing but isentropic compression, which is important to us for this particular question. So this is isentropic compression, and you can just apply the isentropic equation, which is a P to the power gamma should be constant, and you can find the pressure at temperature at the end of the cycle, which is at point 2 at end of this process 1 of 2. So that will be like easy to you just apply that P1 V1 to the power gamma should be equal to P2 V2 to the power gamma, and you will find P2 as P1 into V1 by V2 to the power gamma, and V1 by V2 is nothing but the compression ratio, because V1 will be the volume at that point, which is a volume before compression, and V2 will be the volume at that point, because which is the volume after compression at point 2. And the volume before compression divided by volume after compression is nothing but the compression ratio. So this will become your compression ratio. And you have P1 as 1 bar, V1 by V2 as 14 to the power 1.4, which will be 14 to the power 1.4 is 40.23 bar as your pressure at point 2. And similarly, you can just little tweak this equation into like if you know the ideal gas equation as P is RT, where R is the kilojoule per kg Kelvin, the unit of R is in P kilojoule per kg Kelvin, then you can place the P as RT by V. So R1 T1 by V1 into V1 to the power gamma is R2 T2 V2 into V2 to the power gamma. So T1 V1 to the power gamma minus 1 is equal to T2 V2 to the power gamma minus 1, because R can get cancelled because R is nothing but a constant. So again you have T2 as T1 into V1 by V2 to the power gamma minus 1, and T1 is nothing but 300 as given in the question, into V1 by 2 again will become compression ratio, which is 14 to the power gamma minus 1 is 0.4. So 14 to the power 0.4 into 300 becomes 862.1 Kelvin. This should be our T2, which is the temperature after compression, and P2 will be the pressure after compression. So this was a very easy question. If you know the basic concept that the process 1 to 2 is isentropic compression, so you can apply this isentropic condition, which is PV to the power gamma is constant. And after tweaking this, using ideal gas equation and tweaking this equation, you can find out any more or less anything. Like if you need a T2, you can find it. You can also find V2. You can find P2 also. So just change this equation into different forms. Imagine if you have pressure and temperature, and you need to find like volume. So you can find that also using this equation. If you have temperature, you need to find volume. You can also do that. So just change this equation according to your need, or according to the things you have been doing and things you have been asked. So yeah, that is how you can solve questions like this. Thank you.